You are a lobsterman hauling traps before sunrise. 40 traps come up the usual murky brown. Then the 41st comes up different. Inside, glowing under your headlamp, is a lobster that doesn't look real. One side electric blue, the other side bone white. Your hand is an inch from the shell when your alarm goes off. You lie there, heart pounding, running the odds in your head. Could something like that actually exist out there? Statistically, the odds are almost too small to write down, but that raises the real question. To answer it, we need to break this animal down, trait by trait, starting with color. Almost every lobster you have ever seen was the wrong color. The red one, the one on the restaurant sign, the one in the boiling pot. That color does not exist in a living lobster. Not once, not ever. Red only happens after death, after heat destroys the protein holding the pigment back. The lobster you picture doesn't exist in the ocean. It only exists on your plate. A living lobster is dark, greenish-black, muddy brown, built by evolution to disappear against the rocky seafloor of the North Atlantic. Camouflage is not a bonus feature. It is the entire survival strategy. A lobster that cannot hide is a lobster that gets eaten. Sometimes the system breaks. When the genetic pathways controlling shell color malfunction, the result is a color that has no business existing on an animal whose survival depends on invisibility. The most documented rare color is blue. A genetic mutation shifts the shell's reflected wavelength toward blue. The result is a lobster that looks less like a sea creature and more like something someone painted. The odds of catching one approximately 1 in 2 million, according to the University of Maine Lobster Institute. But blue is not even close to the rarest color. Yellow lobsters exist. A mutation removes the dark pigmentation entirely, leaving only warm yellow-orange tones behind. Odds roughly 1 in 30 million. In 2021, a fisherman named Dale Dunning caught one off Maine. After 2 decades on the water, he had never seen anything like it. Then there is the white lobster. A near-complete failure of pigment production. The shell comes out translucent, pale, almost glowing. Estimated odds 1 in 100 million. In 2019, one was caught off Nova Scotia and immediately donated to a marine research facility because the researchers who saw it could not believe it was real. And then there is the calico lobster. Calico lobsters carry a mutation that produces irregular patches of orange, black, and yellow. A mosaic of color with no consistent pattern. No 2 calico lobsters look alike. Ever. Odds 1 in 30 million. They are so visually striking that nearly everyone caught in the last 20 years has been donated to an aquarium rather than cooked because the fishermen who found them simply could not bring themselves to put them in a pot. We will give our rarest lobster the calico mutation. Current probability 1 in 30 million. Now we go deeper. In 1977, a lobster caught off Grand Manan Island in Canada stopped marine biologists mid-sentence. It was split perfectly down the middle. Left side female, smaller claw, female reproductive organs. Right side male, larger crusher claw, male reproductive organs. One animal, 2 sexes. Divided by a line running straight down the center, as if someone had drawn it with a ruler. Scientists called it a bilateral Gynandromorph. It happens when an embryo experiences a cell division error at the very first split after fertilization. 2 populations of cells develop independently, each following its own genetic instruction set. The result is an animal that is simultaneously, structurally, completely both, in one shell. The estimated occurrence approximately 1 in 50 million, according to the New England Aquarium, which has received several of these animals over the decades. We give our rarest lobster bilateral gynandromorphism. Combined probability so far 1 in 1.5 quadrillion. Nature apparently had more ideas. Lobsters do not show conventional signs of aging. They do not slow down. They do not shrink. They do not become less fertile. A 2007 study in the journal Aging Cell found that older lobsters actually showed higher levels of telomerase, the enzyme that repairs chromosomes, than younger ones. In most animals, telomerase declines with age. In lobsters, it does not. They still die. From disease, predators, the physical exhaustion of molting a shell that gets heavier every year. But they do not deteriorate the way everything else does. The oldest lobster ever reliably documented was caught in 2009 off Newfoundland. Researchers estimated its age at 140 years. It weighed 20 pounds. It had molted its shell over 100 times. It had outlived every human being alive when it was born. We give our rarest lobster maximum longevity, a century-class animal, the probability of surviving past 100 years in the wild less than 1 in 10 million, combined probability 1 in 15 quintillion, now the final layer. In 2006, a lobster caught off Newfoundland had an extra claw. Not a regrown claw from injury. A structurally complete, fully formed third claw growing from the joint between the body and the right walking legs. A limb that had no reason to exist. It happens when a mutation in the homeotic gene pathway, the genes that determine body segment identity, misfires during embryonic development. A body segment receives the wrong instructions, grows a limb where no limb should be. Fewer than a dozen confirmed cases exist in the scientific literature. The Bigelow Laboratory for Ocean Sciences places the probability at roughly 1 in 50 million. We give our rarest lobster a supernumerary claw. Let's recap what we have built. Our rarest lobster is calico colored, an unrepeatable mosaic of orange, black, and yellow that no other lobster on Earth shares. It is a bilateral Gynandromorph, male on one side, female on the other, split with geometric precision. It has lived for over a century, surviving every predator, every net, every disease the North Atlantic threw at it for 100 years. And it carries a third claw, grown from a gene misfiring at the exact wrong moment during the first hours of its existence. The combined probability of all 4 traits in a single lobster, 1 in 750 quintillion. There are an estimated 1 trillion lobsters in the world's oceans. You would need 750 million copies of every ocean on Earth filled to capacity before the math says one like this should exist. And yet, the ocean does not read the math. The ocean just runs the lottery, every spawning season, across every clutch of eggs. A female lobster releases up to 100,000 eggs per brood. Each one is a separate roll of every genetic die simultaneously. Most come up ordinary. But somewhere in that arithmetic, in some dark water off the coast of Maine or Nova Scotia or Newfoundland, the numbers could have already landed exactly right. A calico Gynandromorph, a century old with 3 claws sitting on the seafloor right now, waiting for the 41st trap. The math says it shouldn't exist. But you exist, and the odds of that weren't great either.